we've been working with NASA quite a while. Space Station was done in 3D. So we chose 3D just to be able to put the viewer into the spacecraft with the astronauts, to put them with the camera as it travels through the universe. It's just a more immersive medium to work with, especially in space. It's a natural, you have the third dimension naturally, things float, and so it seemed to be the natural thing to do. For the Hubble film, we had one IMAX 3D camera on the space shuttle right next to where they were docking the Hubble Space Telescope. So we were able to see the astronauts opening up the telescope, getting inside, making all the repairs. Then when we were filming the ground shots, we had as many as 5 IMAX cameras, 3D cameras, at the Kennedy Space Center, shooting the launch, the liftoff, the preparation to launch, the astronauts as they're relaxing and having a bit of family time before the launch. So in all, I think for launch, including the one on the orbiter, we had 6 cameras at the Kennedy Space Center. Unfortunately, this is the first time we've not been able to fly a regular IMAX camera on board in the crew compartment, the area where the crew lives on the space shuttle, because there just wasn't enough room. They had to have 4 spacesuits, they had to have all these tools, they had 7 astronauts, so there wasn't room for our big IMAX camera to fly. So what we did is we used a high-definition digital video camera to record inside the crew compartment. Those images, and those were 2D images, so we took those 2D images and through a computer process that IMAX uses, we were able to create 3D from those. Basically, you're creating a second point of view, a second eye to project on the screen. So we made, call it pseudo 3D from the 2D images. Many of the images that we had from the previous launch, we had filmed the original deploy of the telescope and the first repair mission. So we had those images in 2D, which were also converted to 3D by the same process. And it's basically just creating a second eye, which is usually the left eye, from your 2D images. So you just offset the image a little bit, and then you have to fill in the spots where things were missing, and all that's done by hand. So it's a very labor-intensive process to create the second eye for the 3D. In space, our 3D camera is in a specialized container. It has to have some atmosphere in order to keep the film flat during exposure. So we put it in a slightly pressurized housing with a window. And whenever we want to film, we open the window, the camera takes the pictures, and then we close the window back up. We don't really have too much radiation protection. It's a big issue for us because at the altitude that Hubble is orbiting at, there are some very active forms of radiation there which can destroy high-speed film. So we use a lower ISO, a lower speed film to get away from the radiation possible damage that could happen at that altitude. As for our microphones during launch, we use cheap ones because we know they won't last. We'll place them at various interval distances away from the orbiter, and that will, as one of them gets blown apart, the next one picks up. As it gets blown apart, the next one picks up. So it's a matter of using throwaway microphones and just making sure they get the part of the launch sequence that they were intended to get. So it's just a step back process. As one blows up, the next one takes over. At launch, the sound pressure is so great near the pad that humans cannot actually be there. Just the sound pressure would kill you. But these pressure waves coming from that ignition we put our cameras into special boxes, into very heavy, thick-walled containers that are bolted into place. We'll actually drill into the concrete and use big giant half-inch bolts to bolt it into the concrete, and then there's a optically flat glass window that the camera looks out through. And on previous missions, actually on a Russian Proton launch, when the Proton launched, it blew a bunch of stuff up, and a rock hit our window and broke the window, which was really pretty cool. We kept it in the movie. Everybody takes their glasses off and says, "Oh, it was the window and not my glasses that broke." But no, it's a big process to make sure your camera doesn't blow away and it's in the same place where you left it when you come back after launch. As well as being the director of photography for the film, I'm also the astronaut training manager, which means I am responsible for teaching the astronauts how to do my job. They have to go and take exposure readings, they have to set the lenses, they have to do focus, they have to shoot the shot, they have to light the shot. Everything that a film crew does on Earth with 5 or 6 or 8 or 10 people, the astronaut crews have to do it in space in 0G with about 2 or 3 people. They have it a lot easier because if they drop something, it doesn't fall and break like it does here on Earth. It just kind of floats there. So that makes it easier for them. But they tend to be very good students. They learn very quickly, and they are very excited about being able to bring the experience that they have on orbit back to be able to share it with the IMAX audience. We would love to make a new film. The next generation of space telescope is the James Webb Space Telescope, due to be launched in the next few years. We'd love to make an IMAX movie about that telescope. It, however, I think is going to be a little bit further out than we have capabilities to handle IMAX-wise right now. But it would be great to be able to be out there and see them put this new telescope to work, because it's much larger than the space telescope now, than the Hubble, and will be capable of looking back almost to the beginning of time and seeing what the universe was like at that point. And it's very exciting. So hopefully we'll be able to do it in IMAX, but right now it's a few years off.